Hello and welcome to Game Revolutions, the series where I write code the way they did 35 years ago. Except for the fact that I'm using a full screen editor on a PC and a cross-assembler and I'm using an emulator debugger. Other than all of that stuff, it's exactly the way they did it back in the day. Today's episode is because of a comment that I received from Curtis Boyle on YouTube. He gave me some advice on how to make the animation look a little more peppy by squishing the tires. The old Moon Patrol game would squish the tires in response to actual gravel on the ground, but I'm too lazy to do that, and Curtis's idea indulged that laziness in me, and it was a clever way to have the tires squish just in a regular pattern. Will it look good? Will I be capable of doing it? Keep on watching to find out. This is the basic program that I use to draw all the frames of the car. It then grabs the bytes of the car and saves them into separate binary files on the Coco disk. I've shown this before, and the part where it does the animation is down in here. These are the X and the Y coordinates of the reflectors, and it just kind of goes through this for each frame so that the reflectors are somewhere different each time. So to this I've added some more data. Every time there's a 1, that means the tire should be squished. So for now, I have the tire normal for 3 frames, squished for 3 frames, and then normal for another 6 frames. And the right one is squished for these 3 frames and then normal for the rest. So it should kind of look like the right tire will encounter things first, so it's going to get squished as if there was something on the ground, even though there's not. But it'll look like it gets squished, and then once it's back to normal, left gets squished, and then they're all normal for a while before the right one gets squished again. I read those 0s and 1s here into these arrays, squished left and squished right. And when it comes time to draw the tires, I take a look at that value. And if it is 1, then that means, for example, for the left bottom will be at 166. That'll be squished. It'll be a bit higher. Otherwise, if it's 0, the left bottom will go down to 168. And then I have the same thing for the right tire. And then the LB and the RB are used here as I draw each wheel. And as usual, as each frame is finished rendering, we save it to the ref file on the Coco disk. And in fact, let's run through this. I'll show you the whole workflow that I do, and then we'll take a look and see what it looks like. So starting off here, my disk currently contains these files. You'll see there are no ref files yet. So I will run poke refl. And you'll see at the top is where it pokes all of the bytes so that it can have some place to save them from. And if you look here, you'll see the tires get squished during some of the frames. And now if we do a dir, we see all those ref files. So ref 1, 2, 3. So these are those collections of bytes that you saw at the top of the screen. And my next step is to run this batch file, which uses toolshed to copy all those reflector files from the Coco disk to my regular hard disk. And so now we'll see on my hard disk, I got a bunch of ref bins. And that brings me to one of my Java helpers. This bin to FCB takes a bunch of bin files and turns them into FCB statements that I can paste into my assembly language file. You'll see I use this for a lot of different things. For now, we're using it for the series of reflector files. So it knows to skip the preamble, that offset start equals 5. This gives it the length, and this says when it formats the FCB lines, how many FCB bytes per line. And down here in main, we have a loop that goes through those 12 reflector files. And for each one, it calls the main method to do its thing. Basically, it just reads those bin files byte by byte. For each line, those bytes are added in order, but the lines themselves are printed in reverse order so that this is stack blasting ready. So let's run that. And here we have it. So the next step is to copy and paste this into the file. And here is where it all gets pasted, all 12 frames. So now I build, and I load it and run it. All right, so if you take a look, those wheels are definitely squishing. And if I slide, the squishing action goes around with it as it's sliding. As I jump, well, that is kind of weird. It doesn't make sense that the tires would be squishing while it's jumping. So I probably need to do something about that. Well, as you're about to see, I no longer can be lazy. This change is no longer a nothing change. So the first thing to look at is the basic code that generates the frames. The idea now is I need to generate frames for the 12 steps when the car is on the ground, but also have frames generated for whenever the car is jumping. And so those are going to be the old frames, the frames where we're definitely not squishing the tires ever. So we still have this code here, which asks if we're supposed to squish the tire, and if so, we change the left bottom or the right bottom. But now we ask if we're supposed to squish at all. So I refactored the code that generates the 12 frames and generated them twice. One where the squishing is turned on, which means you should obey those arrays that tell you whether it should be squished or not. And once where the squishing is turned off, which means don't even bother looking at the array, you're definitely not going to squish the tire. And let's run the new version. This time I'm going to leave turbo mode on. So you can see we got some squishing action happening here. First the right, then the left for a few frames, and we finish out the rest of those 12 frames with them not squished. And then we're going to do 12 frames with them not squished the whole way through. And what do we get? We get the ref ends, because that's the ones where it's not squished, and the ref y's, which is the ones where it might be squished, depending on the frame. And after running toolshed and then the Java helper, I end up with now 24 frames. So the first 12 are with the reflectors and potentially squished tires. Doot, 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 doot. And then finally, definitely no squish no matter what frame, all of those. And of course I had to add some code to manage all of the new frames. So I already had this code here, which on each iteration of the main loop would advance the car frame pointer by 30 bytes, since that's the size of it. But then all of this stuff is new here. So if we know that we are jumping and we need to wrap around, then we do something special. And if we know we're not jumping and we need to wrap around, then we do something special. And that special thing is whether we wrap around to the very beginning of all of those frames, or if we wrap around to the second version of all of those 12 frames. And when the jumping is complete, we know we need to switch which block of frames that we're using. But we don't want to lose our pointer into which offset of those 12 frames we're actually at, because we still want the reflectors and the flashing lights to appear smooth. So we just do a little funky math here to go from one buffer to the other. And when we start jumping, it's the same thing. We need to advance to the next block of frames, but retain the same offset, the same relative offset into that new block. All right, pretty good. We are on the ground. The animation is still okay. And if I jump, okay, jump, it still squishes, and then we see little pieces of the enemy, which I haven't even resurrected yet, shows up when we come down. It's almost like it crashes onto the ground, And the tires never... Okay, got a bug. There's no need to panic, everybody. Okay. I've got this completely under control. Okay, guys, I found the problem, and it's this. You even saw this code. I went over this code, and I showed it to you. No one spoke up. Come on, folks. I could use a little help when you see something obvious. Just let me know. So the idea here was, if we're not jumping, then we skip all this stuff that I was showing you. We're not jumping. And instead, we just make sure we run through the block of frames that are the non-jumping version. So what am I doing testing this? This is the pointer to the bytes for drawing the bottom of the car. I added one and I tested what was there. I don't remember what I was thinking. I meant to do this. This is the global pointer that tells us whether or not we have a pointer into the jumping offset table. That's the table that tells you how far up or down the car is supposed to go. And if this dude is negative, that means we're not jumping. I don't know. I don't know. Anyway, I'm sure this will fix it. Okay, squishy, jump. Ooh, I think that did fix it. Huh. All right. Neat. There we go. See, I told you I had it all under control, and you didn't believe me. Squish, jump, no squishing. Jump, you'll never see it squish when it's in the air. Aha! Okay. But now, we also need to look at the amount of squishing happening. I've been looking at this a while. I'm kind of getting used to it, but honestly, I think it's a little too much, don't you? Too much. I think I should be squishing a bit less. So I'm going to change that number, regenerate these thingies, and see what that looks like. Okay, it's definitely more subtle now. Is it too subtle? Can you not really even tell that they're squishing? And I jump, they don't squish. They don't squish. If I slide it a bit, is it noticeable? Was the other too much and this is too little? Whatever, I'm going with this. I think this is better. The other was just kind of too much. In the next video, you will see me work on yet another viewer idea, this time to speed things up. Until then, thank you as always for watching.